Welcome, welcome. For this lesson, we're just going to go through the Unit 4 portfolio as a review. So these are not going to be a walkthrough of the exact portfolio questions, but if you go through these steps following the Amplify activity that's on my message board with it, then you should be very prepared to get 100% on that portfolio. Remember, if you don't get 100% of the portfolio, you can do the portfolio redo after and still be able to make corrections to get it up to 100. But better to get the 100 the first time, right? So we're going to go through this, and this is a relatively short lesson, but it'll go through all that you need to be successful on that portfolio. So again, looking at these sides, this is going to be an important first part of the portfolio, is making sure that you can look at a reference angle and label which side is the hypotenuse, opposite, and adjacent side. From that, you're going to have to say what trig functions you'd use, the sine, cosine, or tangent, based upon your reference angle, and then be able to solve for x. So these are things you had to do on the Unit 3 test. There's nothing new here, except for this is the main idea from Unit 3. So if you were struggling with that, maybe go back and review the Unit 3 notes as well to make sure that you're successful for this portfolio. All right. So this is, again, kind of similar to what we're going to be doing on the portfolios. You're going to have to choose which sides are the opposite, adjacent, and hypotenuse. Now keep in mind, it does label your reference angle. So if we look where A is, the hypotenuse is always going to be the longest side. Kind of easiest to get that first, right? Next, if from that, this is where it gets tricky, you need to make sure that you notice the A is that top one, the adjacent is going to be the side next to it. Adjacent, next to, it's whatever the reference angle is, right? So if A was in the bottom left, that would switch. The adjacent would be at the bottom now. But since the A is at the top, the adjacent touches that, the opposite is the side that doesn't touch it. So if you can correctly understand that first part, it's kind of the puzzle, right? Making sure you choose which angle you're looking at correctly, and I'll label it, tell you which angle to look at. Then the hypotenuse is still always going to be the longest side. The adjacent and opposite is based upon that angle. So just make sure we are careful there. All right, we've got another one that's the exact same. So here we've got a reference angle down at the bottom right. So my hypotenuse, always the longest side, easiest to mark that first. The opposite, the side it's not touching, and the adjacent, the side next to that. So again, if the main reason I know where the opposite and adjacent angles or sides are is based on that reference angle. A is marked on the triangle. That's what our reference angle is. If the A was in the opposite corner, we'd have to switch the opposite and adjacent. So that's what makes this so important, is it's all based upon that reference angle. Okay, let's do one more of those. So keep in mind, it's easy to identify where the hypotenuse is. It's the side opposite of my right angle, the longest side. So I should be able to get the hypotenuse as long as I'm kind of looking at that. Now, remember, right triangles don't always have to be facing the same direction. They might flip it upside down, and maybe your right angle's at the top instead of the bottom. But you can identify that, right? Look at it and identify where the triangle is. So the adjacent side, the side next to my reference angle, the opposite, the side not touching it. All right, that's a few points on the portfolio is what we just did. So if you can do that, you've got those down. All right, now we're going to solve. Now we can go through and first mark this up with our hypotenuse, the opposite, and adjacent. I know those because it's given me this reference angle, so I'm going to use that reference angle to solve. Now in this case, the SOHCAHTOA, I'm going to be looking for my opposite, and I have an adjacent. My hypotenuse doesn't matter here, right? I'm not trying to solve for that. So with opposite and adjacent, I'm looking for my tangent function. So I have the tangent of 24 is equal to the opposite, which is x in this case, right, over the adjacent, which is 12. Now I've said this before, hopefully you guys remember it. If x is high, you multiply. If x is low, divide and go. So x is up top, so we're going to multiply. So 12 times, not divided by, the tangent of 24. Now I get 5.34. This one says round to 1 decimal place. So I'm just going to make sure I just round 5.3. because the 4 would round down, right? It's not 5.4, 5.3. Yay, correct. You will get those wrong if you don't double check your 1 decimal or 2 decimals or whole numbers. So make sure you're checking that in your problem. Okay, we have another example. Again, this is the whole portfolio, just being able to solve these types of problems. So here, if I want to label it again, my hypotenuse from that 49 degrees, this will be the opposite side and the adjacent side. Now I'm going to use the tangent function again because I'm looking at the opposite and adjacent. So my tangent of 49 degrees is going to be equal to 14 over x. So this one is not going to be solved the same though, right? If x was high, I multiply. X is low, divide and go. So the 14 divided by, not multiplied by, the tangent of 49. And here it says round to 1 decimal place, but since it's 12.17, that 7 is going to round it up to 12.2. 12.2. And again, if you have rounding errors, you will miss these. So make sure we are not missing the rounding. Okay, and we got it. Correct. Yay. All right, next one. We've got a problem. Now, this is where some students struggle because, as you can see, my right triangle is kind of flipped, right? So this is still my hypotenuse as the longest side, but it's not in the same place that you might have been looking for it. You just got to make sure you're identifying where that right angle is also for my hypotenuse. Now my reference angle is up here at 21 degrees, so the side opposite of that is my x, and the side next to it is my adjacent. Now we don't see anything labeled on the adjacent, right? We're not using that. We do see that our opposite is the x and our hypotenuse is 22. So we're going to be using our sine function since we have the opposite and hypotenuse with information we're working with. So the sine of 21 is equal to, and again, the opposite is x over the hypotenuse of 22. So x is high, we multiply. So I'm going to take my 22 times the sine of 21. And I get 7.88. Now again, we're rounding to 1 decimal place. So 7.88, that second 8 is going to round it up, right? So since I'm just going to the 1 decimal place, I can't just leave it at 8 because it would have rounded it up to 7.9. Now I don't put 8 for the whole thing because I'm rounding to that decimal, right? If you need a review on rounding, because I know a lot of students still struggle with that, make sure you stop into tutoring for that, or watch a Khan Academy or YouTube video on rounding tips, and they can sometimes re-explain it. It helps you kind of get those a little easier. So 7.9, because 7.88 will round up to that 10th place. Okay, we're just cruising through a couple more examples. So again, I want to see that this is not, how we typically would draw these right triangles. It looks like it's flipped around. But this longest side is still the side opposite of the right angle. My reference angle down here, right, means that this 21 is my adjacent side, and the x is my opposite, because we're opposite of this reference angle. So in this case, we are going to be using opposite and adjacent. So we have a tangent function again. Our hypotenuse doesn't matter here, right? So the tangent of 68 is equal to the opposite, which was x, over the adjacent, which is 21. Following those rules, right? We have that rule written over here, the sine, it's opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent. This is information you can use on the portfolio and on the tests. So the opposite over adjacent means we have to set it up that way. The opposite over the adjacent. Now x is high, we multiply. So same thing, 21 times the tangent of 68. Now we are going to round to 1 decimal place. Now this one, as you can see, says this is 51.97. 7 rounded up. We are going to round this out to 52. Now, on this one, it'll probably let us just do 52. But if you put 52.0, you're even more correct. So, it's okay when you have 0.0, because it's not a significant number, to leave it as 52. But get in the habit, because your college teachers might not be as nice on that, and they will require that you write out 0.0 to make sure that you understand you didn't that it's rounded to that 10th place. So it wasn't rounded to a whole number, just in case. So 52.0 or 52 would still be correct here, though. All right, we've got just a couple more to review, because again, that's very similar to the portfolio, right? So this one's kind of fun because we have the degrees and the side length being similar, right? Kind of throw you off maybe. So in this case, we're going to see that the side opposite of my right triangle over here, right, the right angle, not right triangle, right angle, is the hypotenuse. From that reference angle, the side next to it is the adjacent, and the opposite over here. As you can see, we're not using that opposite at all, right? There's nothing over there. But we are using the adjacent as our x, and the hypotenuse is here. So we have our cosine function we'll be using. So the cosine of 56.1 degrees is equal to the adjacent, which is our x, over 56.1. Don't be fooled, that's intentionally written those percentage numbers to be the same just for fun, right? So x is high in our fraction, so we are going to multiply it. So I have 56.1 times the cosine of 56.1. And we get 31.289. We are going to round that to one decimal place again. So 31 point, instead of 2, it's to 8, right? So that's going to round it up to 3. So we have to look to that next number to make sure our 10th is rounded correctly. And we got that one. Yay. All right, number 6 here. We should have this and 2 others. So you guys are doing great, following along with the Amplify activity, hopefully. Getting a good idea of how to solve these by doing a bunch of practice on them. Makes it much easier because you do it a few times, you'll be an expert. All right, let's label our sides. It's a good way to start out. Make sure we're not getting lost. Here's our hypotenuse, the longest side. From our reference angle, this will be our adjacent side and the opposite. So it looks like we're dealing with cosine again, right? Because we have our adjacent and hypotenuse. Remember, that's where our cosine function would live. So let's go ahead and put that in. Cosine of 47 is equal to the adjacent's 28 over x. Now we're getting to practice one where the x is low on the cosine function. So x is low, divide and go. So 28 divided by the cosine of 47. We are going to round this to one decimal place again. So since we have 41.05, 5's round up. So it's not 41.0, it's 41.1. Because we have to round that 0 up to 1 because the next digit would be a 5. Right? And round 5 and higher. It's 41.1. Alright, 2 more. We're doing great. Let's go ahead and label our sides again. We see where our right angle is down here. And so this will be our hypotenuse. Here's our reference angle. So the side opposite of that is down here, the 2.06. And the adjacent's the side we're not going to be using here because there's nothing over there, right? So in this case, we are looking for the function that uses our opposite and hypotenuse, because this is where the question mark is, right? And this is where our 2.06 is. So we have our sine function for opposite and hypotenuse. So we're going to do this again. That's the sine of 24.3 is equal to the opposite, which is 2.06, over x, our hypotenuse. So putting this in the calculator, and you make sure if you aren't using the calculator built into the activity, there's a settings on the Desmos calculator so you can change it from radians and degrees. If it's in radians mode, all of your answers will be wrong. And it defaults to that if you just go to the Desmos calculator. So make sure it is in degrees mode. Now in this one, it's set up for degrees. So if you're using the Amplify calculator, you could just use that, right? Have that open. You're good to go. But if you go and find another calculator online, make sure it's in degrees mode. Okay, let's go ahead and put this in. We have x is low, right? So we're going to take the 2.06 and divide it by the sine of 24.3. Now again, we are rounding to one decimal place. Since this one, 5.0, the next one is 0, it'll just stay at 0, right? So I could just leave it at 5, But since we should have one decimal place listed, 5.0 is going to be correctly rounded. So even though it's 0, you're thinking, well, that's still 5, right? But we want to show we did round it to that one decimal place. That it wasn't something that we rounded to a whole number. Okay. Last question. Now this one we do see that we have a 45, 45, 90 triangle, but it's asking us to solve it to a decimal, so we would have to put it in our calculator regardless. But if we wanted to take a shortcut, since we know that's 45, then we know this other side would be 35, and the bottom would be, because it's the opposite of the hypotenuse, 35 times the square root of 2. But we'll go ahead and do this. I mean, we can do it both ways, we can see, right? So let's go ahead and do the trigonometry function and compare it, just so you can see, how that shortcut works. So in this case, my hypotenuse is on the bottom, right? And the opposite side is 35. So if I wrote that out, that's not let me draw, but it would be, we'd have the opposite is 35 over x, right? So x is low, divide and go. So we'd have 35 divided by the sine of 45. And you see we got this one as 49.49. If we round that to one decimal place, it's 49.5. But I'm going to show you if I did 35 times, remember this is our special right triangles of 45, 45, 90, and it would be 1 to 1 to the square root of 2. So look at that. 35 times the square root of 2, we have identical answers. So that's why it's sometimes just easier to remember those rather than having, is it sine, cosine, tangent? You see the 45, 45, 90, you know it's the hypotenuse is one of the legs times the square root of 2. So that kind of makes that shorter to solve. Alright, but when I do put in my answer, I have to round it to the one decimal place. So 49 rounds up to 5. I have 49.5. Alright, well that is it. So, hopefully you guys are ready for that portfolio. Again, you can always stop into tutoring if you have any questions. Shoot me a web mail, text message if you need. But enjoy, have a great day.